So, are we live? I think we are live. I think we are live. I think we are live. I think good. Just 1 second. So hopefully you guys can see my screen and we are in fact live. Let me just look into something here really quickly. Okay. Now. So hey guys, how are you doing today? Let me just have a really quick sip of my tea. And yeah, so today what I want to do is basically continue to work on the type inferencing and type checking for my language. My last string, I think I did some work already, but offline I got to some conclusions while I was doing other things, and I think I need to change how I am basically handling a lot of things, and I did some work to make it a little bit easier, simplifying a bunch of weird shit that I was doing that didn't really work well. So I can even show you more or less what we have. So basically here is the file that we are using for testing. Don't mind this is just some weird things that I was trying. So I can actually just not worry about this, but here it is. So basically we have 3 variables. We are assigning them to new variables, and then we are assigning these variables, the 3 initial variables, to new variables that we are specifying the type, and the types technically should match. So if we try to run this and we do it like this, it should just work, and I can even check the output, and it's 0, so it means it worked, which is fine. And we can probably do something like this. I am expecting a boolean in here, but if I try to do this, it will fail, and it will say that there's an error for the types that the new value 2 was expecting. There's a typo in there, but whatever. So it is in fact working, you know. It is even working for things like function calls. So if you take a look, it is inferring whatever we got in here. There's a warning, but that's okay. But we in fact are inferring that correctly. You can say that this is a string and it should work just fine. But if we do something like boolean, for instance, it should fail. It doesn't. That's okay. That's part of the thing that I want to fix later. But it is in fact working. Okay. And what I did basically, so let me close this. If we go to SRC, and then previously I basically had 2 types. I had 2 files, one for type checking and one for type inferring, and basically didn't really work out the way I was expecting, specifically for more complex expressions. So for simple things like the ones that I was showing before, so for things like this, it works basically. It's okay. We can have different files for type checking and type inferring. They can happen in different situations, and that's fine. But the thing is, when we start to have more complex expressions, so for example, we have a complex expression that is like 1 plus 2 plus some function, you know, it is kind of hard, because this is supposed to be a sine 64. This also needs to be a sine 64, and they both need to be the same type for the plus operation to work. And not only that, the function needs to also be sin64 as a return type, otherwise it should be an error basically, which makes me, which the thing is, we are trying to infer something, right? And if we say that this is a number and this is a number, but we don't really know anything about it, we basically need to type check and infer at the same time in this instance, because we may not know what is this and if it actually works with the plus operation, and checking if this entire expression is valid only happens at the type checking and not when we are inferring. We could do them both. So when we are inferring, we are checking that those are values that are matching, but later we need to type check them anyway, which is kind of weird. So why even bother having two steps if they need to happen at the same time? So instead of having two separate files, I basically moved everything to one file, one giant file that is responsible for pretty much everything right now. So it's not that big, it's just 200 lines. The idea is that I'm going to improve it today. There's a lot of things that I'm skipping, so the binary operations is one of them. The function call is another one that we are not type checking or anything. We are kind of type inferring a little bit, but not type checking. We also need to think about a solution, but I don't think we are doing this today because it's kind of too much. But we need to think about a solution for the type definition for functions. So if you take a look, we don't have basically a way to define a function pointer. So if we have something like fun, and it's basically just like a proc that returns a string or maybe something. So this is technically a function pointer that it is expecting. So it's expecting a procedure that returns a string. There's no inputs, which means that later we could have something like fun is basically equal to function, I guess. That's something that we could eventually do because they are matching the expected type, but we don't really have that. We don't have that, how can I say it, definition. It's not really a definition, right? We don't have the signature as a type, I guess. So yeah, this is something that I need to think about how I want to handle, because right now we don't really have a good way to do that. So if we take a look at this, you can see that when we go to procdef, in here we basically have just the scope, the inputs, the outputs, and the arity. We don't really have a, what was the word that I was using? We don't have a way to define the type, basically. We don't have the signature of the function. So there probably should be a way for us to define a signature so that we can eventually compare later. But, you know, it's something that we can do later, not today, which is okay, I guess. It's fine. So now that I have explained to you what we have, I basically want to go over everything that we have so far and see if it is in fact working. So let's do this. Is this working? It is not. Why? Because yeah, it's because of this basically. So if we take a look, they are basically saying that value 1 expected signed or unsigned integer, but the thing is we are not doing type checks for we are not doing them properly. That's the problem. We are not checking the scopes, because previously I introduced different scopes, and the code that I was using for type checking was not considering scopes, so it is kind of messed up and fucked up and weird. That's why the error message is just this weird whatever, because we are not considering scopes and it's weird. So let's probably fix this now. I think that's a nice thing that we can probably do. So let's go into the inference. So this is the identifier. Yeah, so in the identifier, basically we need to consider scopes, and we are not technically considering any scopes. That's the problem. So if we do this, I want you to see this. We are not even, yeah, we are only considering this in this function, which is, yeah, just at the end, not even anywhere in here, which is not great, I guess. And we are doing some weird ass fucking things, I guess. So let's start simple then, because we already know this is identifier, if I'm not mistaken. Yeah, in here we know it is identifier, then we infer the type if we can, then we do the type checking. Yeah, so in here we don't do binary operations. I think that's not good, or maybe it is, because yeah, so probably what we need to do is basically mix these two operations together, because we kind of need to do them at the same time. Yeah, I think we need to do them at the same time, just to make life a lot easier, I guess. So let's just try it. So let's do it a little bit differently. So let's comment this out and do something like type check infer and type check identifier or something. And this is just the program and the scope. Fucking what? So here it is. Basically we need to just copy this and create a function for that. And I don't think it is returning anything. It is just doing the job. Because when we are inferring, basically we need to just set the type for the node. And then when we are comparing things, we don't really need to return anything. We just need it to fail, I guess, which is fine. It's just an error message that we need to give to the user because they messed up or something. So the first thing that we need to do, and I think we can take a look in the infer type, no, in the type checker, is this node, for instance, a integer literal? I think that's good enough. If in fact it is, because we already know it is in fact a identifier, and we can do something like assert that the node type, oh yeah, we don't have the node yet, so let's do the following. The node is basically this, and we probably need to get that by pointer. So if the node type is equal to node identifier, otherwise we were expecting a node identifier, but we got, and then we can say something like this, fmtsprintf, and basically we were expecting node type to a string, and this is just the node type. Yes, and that should be fine. So if we find it, it means that this is this node is an integer, right? And the first thing that we need to do is check if we need to infer it or not. So if we go in here, there's probably something in here like U64 or S64, I guess. Inferred, yes. So in here, we basically need to copy this. Yeah. So we are checking in the scope. So even before that, if the node dot variable declaration the type is equal to infer, talking infer if I'm not mistaken, we do this. Token type dot token, yeah, so type that dot token type, sure. If it is the infer, then we need to look into the scope. If we find it, right, if we find something in the scope that matches whatever we get, it means that it is in fact correct. We just need to update whatever is in the scope, and not only that, we need to update the actual node, because we need to do them in the same we need to give them the same information. What do I mean by that? If we go back to here, so let's say something like, okay, if we have a function in here, this function has this scope, okay, and if we have a variable like a is equal to 10 or something, a is only available for this function. It will not be available anywhere else. Now, because we are inferring this, basically we are saying, okay, this is a signed 64 because the default value for integers is signed 64 in this language. So we not only need to update this node, this entire thing is a node, okay, so if you think about how it is implemented, this is basically a node, okay, and we have a identifier, a value, and a type. So as you can see, if it is in fact infer in here, as it may be, we are basically changing the node itself, right? So we are changing this node, and not only that, we need to change the scope that it is inserted in. So for instance, this is not a great example, but let me show you what I mean in here. When we are outside a function or outside of anything for that matter, in our global scope, if we have something like this, this can be accessed by anything basically. So I can even say like, okay, B is basically A, okay, and when we are type checking this node in here, as I showed you before, we are not only updating the node, but we also need to update the scope, which is the global scope that everyone has access to, because later when we are type checking whatever is inside of this scope, it needs to check the global scope to see if that variable is available for them, and not only that, it needs to get the type from that variable that we inferred before. So if we update this to signed 64, as I have in the example in here, as you can see, later we also need to have the same information in the scope, so that when we are type checking and inferring, we can say, okay, this is the same thing as in here because, you know, we have that defined previously. If we don't have that configured, then this would be correct. Okay, so if we don't do the steps that I am showing you, and basically we are skipping this entire thing, right? So if it was never implemented, this would basically be empty and would be null, and that would be a panic in Go, I guess, or something, because it would fail if I try to eventually do something with that. So yeah, that's why we need to have this kind of weird behavior. So yeah, and this is a linear search, which is not the greatest, because if we have a large scope, a large global scope, then there's a lot of things for us to look for. But later, when I am also bootstrapping the language, I'll probably not use this. I'll be using a dictionary or a hash map or something. I just don't want to make it, I don't want that to be a limitation, because when I am bootstrapping, I don't want to have to implement hash maps to make it work. So it's just a preparation for the future when I need to move everything that I already have in Golang to the language itself, to Chaos. And later, when the language is bootstrapped, I can start changing these kind of things from a list to a hash map, which is a lot faster compared to a linear search on an array. So yeah. Now, we did find it. So basically, we can do the following. We can say the following. So we can break, basically. We are no longer returning. We are breaking out of this loop. And not only that, we need to assert that it found something. So we can say found in scope or something. And we can say that the default is false. If we find something, so we found in scope, then we set that to true, and then we can use that as the found in scope. And this assert will work as expected. Because the idea here is, if we don't have something in scope, basically I want to fail. It shouldn't fail in here ever, because we are already doing something in the AST prior to this. But just in case, I want this to fail, because if it ever happens, it is easier for me to say, okay, I failed in here because whatever reason. We never know what will happen in the future. So just for the sake of security, not even security, just for the sake of not making me mad or not going into madness searching for errors later, it's just easier. So in fact, we infer the type, which is great. Now we need to check, right? And another thing that we can probably do is we can have something like this. We can say inferred by default is false. If it enters in here, we can say inferred is equal to true. And now, if it was never inferred, now we can basically do the type checking. Because if it was never inferred, it means that we have already an explicit value that is assigned to this, which is okay, right? So if we infer something, we kind of know the type, and that's fine because the identifier matches the value, so we don't really care about whatever comes next. Now, if we never inferred, because we don't know the type, it means that we can probably check that whatever is in the right hand side matches the type for the identifier, and we can just look for whatever I have already implemented in the type checker, which is in here. So we can basically just do a copy and paste and change a bunch of things because some of them don't actually work. So let's do this. So this is the integer value, and we know it is an integer value. The other thing that we can probably do, just to make this a little bit better, is the following. We don't need to we don't need to cast anything actually, because if I'm not mistaken, in the literals, if you go into literals, it is a token. What? So the assignment, what is the assignment? I don't remember. The assignment is in fact a node, and we can check the node type of the assignment, which makes and then we don't need to cast anything, I guess. So we can say this is the assignment, okay. This is the type for that, and then we can do the following. If the assignment node type is equal, so the first thing, if it is not equal to so if it is equal to, right, I mean, we do know already assignment, we already know this is a literal, so we don't really need to do anything other than get the actual. Do we need the value? Actually, we actually do for reporting purposes, I guess. So one thing that I can basically just do is just assert the cast. So we can just do something like, okay, this is the value, and we know it's the value because it's a node identifier. So this is the assignment, and the literal, because we know it's the int literal integer, and then we can just get the value for that, and we can just cast assert, and that's it. And this is just integer, and that should be fine, I guess. And we don't need assignment. And if it ever fails for some reason, then we just fail, because it shouldn't be a failure, but it's always good to check if it is in fact not working. Again, we know it's a integer, so we can just cast it and assert it is an integer. Now we can just remove this. We have some of the allowed types in here, which means that for integers we have these. Int literal, yeah, because int literals can be either signed or unsigned, so that's fine. There's no distinction at this level, I guess. And then I guess that's okay, so that should be fine. And then we are done. I can just return, not even in here, but in here. So let's double check. We get things by a pointer, because later we need to change them. Then let's make this a little bit better because this looks fucking ugly. So we assert it is what we think it is, just in case. We check to see if it is a integer. If it is, we check to see if we need to infer the type. If we do need to infer, we just set this flag to true. And then we need to say, is this in scope? And we basically are searching for whatever we have in here. Yes. So two things actually. The first thing is we can do this in here, right? No, we can't. We need to do it in here. Yeah. So we are looping in the scope. We are checking to see if we have something that matches, because we need that to match, because we are doing the search. Otherwise, yeah, so that's fine. We are creating the type for the identifier. We are setting this to Science64 because this is the default. And then because we found that in the scope, we do also update the scope. We set the flag to true because we found that in scope, and then we break out of it. The assertion is successful, and we move on. If we did in fact infer, we are basically skipping this because it doesn't make any sense to type check something that we inferred, at least not for now. But in the situation where we didn't infer anything, we are basically casting the value that we got as an integer just for diagnostics. Then, and we can even do something like this. We can put it in here because then we don't need to actually do this operation unless there's an error. So we get the type for the node, whatever that value is. We make sure it is one of these. We create a list of types that we are allowing. Yeah. And then we check if they are in fact allowed. So this is the list of things that we allow, and we are comparing this to whatever we got in here. And we can even double check what it is doing. Yes, it's just a loop that is checking that the allowed types and the variable type matches. So that seems okay. It should be working. Yeah, I think so. Let me drink some tea real quick. We can even test this to see if it is in fact working. So let's... Oh yeah, and one other thing that I need to do in here is basically consume whatever we got, because after we type checked everything, we just consume this to continue the operation. Okay, so let's see if it is in fact working. So this is the first thing. Let's see if it is in fact working. Okay. And one other thing that we can do in here is just print a debug information for the node. Let's see if it is in fact what we are expecting. So value 1 is a Science64. It is in fact a literal with the value 10 because it's an integer, so that's okay. Now let's do the assignment in here. and let's see if it in fact works. It works. We can go in here also, that should be fine. And in fact it is signed64 and it is in fact type checked. We can check it is not doing anything weird, and if I say something like it's a string instead of a, yeah, no, something failed, which is not great. Why it failed? That's interesting. Why it is failing? Let's do the following. Let's, before anything, print the actual node. Before we go anywhere, let's see what we are actually working with. Do we have anything? No. So we should be seeing 2 nodes. And in fact we are. So new value 1, it's a string, and the assignment is value 2. Oh yeah, no, so I am just silly. That's not working because we don't have that implemented yet. So if we do something like this, it should fail then. Yeah, that's my bad. Yeah, it failed. And we can just remove this and you can see the actual error message. So the value 19, expected type signed or unsigned integer, but got a string. That's okay. Let me just roll back to whatever I had before. That was the mistake. I not implemented the assignment for identifiers yet. Okay, it is in fact working, and it is in fact as we were expecting. Nice. Now, this is for integers. Let's now do the same thing, but for strings. So I can even go back in the, yes, in here, string literal. Let me go back. I need to go in here and then here. So if we find a string literal, we basically need to do the same thing as we did in here, but instead of making it a signed64, we just need to do a string. So it's exactly the same thing. So it should be a string in here. And it was found in scope, which is great. Otherwise we need to do this inferring. And now instead of this, we can just remove it and we can say, okay, it's just a string that is allowed for now. And instead of integer, we can just cast it to a string, and then we can say that this is a string. And here is not a digit, it's actually a string. That should be it. That's a simple implementation. It should just work. It does. And if we say this is actually a boolean, for instance, it is going to fail. The evaluate something, expected type for yeah, so the error message is incorrect. Expected, like, I think I have an error message that is actually correct. Cannot infer verbal declaration. No, where is it? Yeah, that's a trash message. So let me actually do something that is better. So in here, fmifs.f, the identifier, whatever is expected a string but got whatever, and then just this. And I mean, I don't even need this, I guess. We can just say the identifier expected this but got whatever, which makes it a little bit easier. We can just say like no dot variable declaration name symbol, sure. And I can even probably do it okay. Yeah, which is a lot better than the previous message, which sucks, and we are casting things and we can just copy it, just do it like this. What? Huh? Where am I? What the fuck? Yeah, here. Okay. So the identifier whatever expected is expected this but got whatever, expect a signed. What is this? Yeah, is signed or unsigned integer but got whatever, which is a better error message in my opinion. So if we take a look in here and then we just change it to a string, yes, we can even do something like this to make it easier for us to understand what we are talking about in here. So identifier value expected sign or sign but got string. Great. It is in fact working. Now what do we want to do? Let's do boolean, and it's basically the same thing. Yeah, it's the same thing as a string, but instead of a string is a boolean. So let's do the following. Copy this. Actually, let me use this one as a reference, and then we can just go in here. Oh yeah, one thing that I forgot, just return. Which is okay. Yes. So in here we are looking for a boolean literal. If we do find it, it is not a string, it is a boolean, and instead of this we can just say boolean. So in here we are only allowing booleans because this is a literal. Expected a boolean but got whatever. It is compiling, but we need to just do this. And it is in fact working. If we say that this is actually a string, it should fail. Yes. Nice. Great. And then we can just return. Now we need to do identifiers, which is a little bit different. And also let me do the following. We can assert false in here, and if we ever reach this, basically there's an error. Unexpected node, and then we can just say what is the node, so fmts printf node to a string, and this is the node dot node type. So if we ever find something, and we can just say this is an error. It should work now. Really, you don't have a type for void in Go, right? Which is kind of annoying. Sure, whatever. I hate the fact that we don't have a type for void, because I thought something like this would work, maybe. But it doesn't. Which is kind of annoying. Yeah, whatever. I can just say any and don't have a return in here, that's fine. It's not like I am using Go because it's a good language or anything. So if we find an identifier and it's not this, but it's node identifier, then we need to do a bunch of weird shit, because there's a lot of different ways, I guess, that we can check this. So let's see what I was doing before, and we can probably update it later, not in here but in here. Node identifier. Yeah, infer node, infer scope. Yeah, I was doing some weird shit in here that I don't know if we need anymore, but maybe we do. So let me just copy and paste this. So the first thing is, do we need to infer it? I guess that I was doing something like this. If, and then let me double check. Yes, if this is an infer, then we do a bunch of weird shit. Infer node. Yeah, I think this is a better solution, because then we just we need to loop in the scope to find the things that we're basically trying to update. Okay. And the thing is, it's a little bit different then, because we need the the first thing that we need to do is say, okay, whatever we have in the assignment, it must be an identifier. But I mean, we don't actually, because we already know it. We can for sure know it is in fact node identifier. Previously, I wasn't sure that we knew, but now we 100% know. And then I can just say that we need whatever we can find in the scope to match it. So what I'm doing here, basically, let me roll back real quick. Let's look into this example. So I am basically assigning something to value 4, and that thing is inside of the scope, and it is called value 1. It was previously defined in here. So I need to look into the global scope until I find this identifier as something on the left hand side instead of the right hand side. And for me to do that, I need to look through all the nodes until I find this symbol and they match. If they don't exist, basically maybe it's out of scope, maybe I never define it, maybe there's a typo or whatever. Either way, I need to find it in some way, and I do that by looking up similar symbols in here. And when I do find it, I need to, first thing is get the type from that thing and assign to this node, because technically we already know this. Okay, we already know, and we know we need to infer. So we are basically getting that information from our previous node. And I think that's okay. And then we just, yeah, and I think that's just it. We found that in scope, I guess. Yeah, so we need to say, we need to infer it. Infer is equal to true, and then found in scope initially is false if we ever find it. So we found in scope and it is in fact true, and then we can just break out of this loop, and we don't even need to do anything like this because we are not creating anything. We are inferring from something that already exists, and that should be okay. Now, actually, we don't break. We need to do something different. Yeah, we need to do the following. Not only we need to find the node, the symbol, right? We not only need to find the symbol in here on our previous nodes on the list that we have, we also need to find the value for the thing that we are assigning and updating the scope for that as well, if we ever find it actually. So it means that we don't actually break in here. we need actually to continue the loop until we find that thing that we are trying to assign, which probably will be the next one, but I'm not 100% sure. But either way, when we find it, and we should find it later, we can even do something like this. We can continue because we for sure know we found it. But if we don't, I mean, if we do, that's okay, let's move on. Otherwise, yes. I mean, can we do no variable declaration name symbol? What I was doing here actually, we continue. Yes, okay, that is in fact correct. Let me just reorder this, because in here we are just searching for the thing that we already assigned the type, but in the scope now instead of what we had. And in fact, this will not always be true. Later this will probably change, okay? Because what I want to do is later I don't want to have a top to bottom kind of thing, similar to what we have in C. So for instance, we have like if we have something like this, and then we do like include I don't know, std or something, and then we do main integer main, and then we do argc argc, it's integer argv into char. If we do something like this, and then we have like print or something like this, okay, if we have something like this and we have a function in here that it is full, okay, and I call full, if I have it like this, full needs to exist before main, okay? If we want to have it later, I think we can, but we just need to do something like I don't even think we can, maybe we can. We need to say like void full, and then we have the definition in here, not the definition, the signature, and we are saying, okay, we do know it exists, but we don't really know how it is implemented yet. Just be aware that it does exist, and eventually you will be able to know this, and then we can do something like this. But this is super annoying to do, because when the project gets big, it is kind of annoying to know where things are, and you need to change things, and you know, that's just fucking weird. So instead of having to worry about this, I don't want people to worry about this, it's kind of annoying. I want people to be able to just go in and say like, okay, here is my main, okay, and for you to define main, you need to do something like this, okay? But then we have a function later that I want to call in main. So in here we would have a function call that is defined after the entry point. The idea is that later there will be a step in the compilation process that sorts everything. So if we have a definition after main, that should still be something valid, because we know where we know where we are entering. So if we know where we are entering, that should be okay, right? That's the bare minimum. And then the only thing that should follow a top to bottom kind of thing should be anything that is in global context, that is a assignment, and it's not a function. So a is equal to 10. This should be something that happens prior to the entry, okay, because this is basically acting like a defining in C. But functions, for instance, this should be just like, okay, it doesn't really matter if it is before or after the entry point. So yeah, for now we are doing this like this, but later it will be a little bit different, I guess. So yeah, so in here we found in scope, and then we are breaking out, and then the other thing that we need to do is just assert that we found that in scope in here, which should be fine. And this basically can be deleted, I guess, for now, because we just changed it to make it a little bit better. Now in the inferred, if we don't have it inferred, then we need to do some weird fucking shit. So let's go into the type checking of identifiers. Inferred type. So here is how we are type checking. We need to get a bunch of things actually. So, and actually before I do that, let me see if it is actually working. The initial thing, unexpected node, okay, but it should, yeah, this is the problem. No, it isn't actually. What? So something is not working in there. So are we even reaching? We are in fact reaching. Are we in reaching here? We are in fact reaching there. Are we reaching here? We in fact are. I see the problem I never fucking returned. Yes, don't be a silly fucking bitch like me. Okay, now it should be working. Okay. So let's do it like this, and it should be working. It is in fact working. And if we do it like I am expecting a string instead of this, is it going to work? It isn't, because I never implemented it. So now comes the part where we need to actually type check shit for identifiers. So if we have the left-hand side type would be this right here. This is the left-hand side type. We need to basically get this from the node variable declaration type, and then this symbol, I guess. Yes, and the symbol would be a string in this situation. Then we need to get the right hand side type, which is this, and this is only available in the scope, which means that we need to actually get the node for that, and we need to check for that. And what we need to do, we need to get the node, variable declaration, then assignment, then identifier. How am I doing? Name, I guess. Assignment dot variable declaration. I don't actually remember. 1 second. No, that's so fucking annoying. I hate Go. I hate this. I hate that I need to fucking do this trash language. Anyway. What am I looking for in here? I don't remember. So let me just... So value 4. I think that's the one that I'm looking for. What is this? So value 1, it's in variable declaration name, but the assignment is no. Why? Why is it no? Huh? What is the And I think I return, right? Yes, so I can just do it like this. It is no. Why? Did I do something wrong? So if we go back to node identifier, is it not this? I thought it would be. Huh. Did I do something wrong here? It should have worked, no? Because we are in fact reaching. Huh? Wasn't it? Did I do something weird? Wait. No, it is. Okay, so yeah, no, I'm mixing things up in here, so... Or am I? Huh? What is the node? It is not reaching, but yeah, no, sorry. Let me fix this, because it doesn't need to infer. So in here we have value 4, sure, is equal to value 1, sure. But why the type is incorrect? When in fact value 1 should be assigned 64. Yeah, it should be S64. Why did I messed something up. When we are inferring something, I am doing it like this. And this is a pointer, so because this is an array, and we are getting the index of that thing and we are assigning it, so it should work. Yeah, it is in here, in fact, but not here. But that's fine then. Yes, that is fine. I am just... that is fine. Index node range for the scope. That's what we are trying to do because we don't know about it. Oh man, I think I'm just tired. I am on 3 cups of coffee, I guess, 3 espressos, so, and I had a rough day today, so that's why. So if we find the what are we looking for? Yes, this is no.variable declaration.assignment.variable declaration, and then we are getting the name and the symbol. It must be equal to this variable declaration name symbol, and then we should have at least one reached in here. Okay, to do any whatever index, and I don't care, left hand side type. Do we have one reached? We do. Where is the other one? Huh? Oh, I see. Just because yeah. So it is in fact working. Now, what do we need to do? I don't remember. So we found it in scope, which means that we can do our operations in here. So we have the variable type. Now we have to get the ident type, which is basically this, but instead of name is type symbol. And we need to type check, and that should be it, maybe. And then we can just break, and then we can just return. What is this? Yeah, that's okay. So in fact we don't need this, or do we? We do. Do we? I don't know. For now I don't care. So we need to get the var type in here. What is it complaining? What is it expecting? It's a token. Okay. And okay, it is expecting in fact a token, so I can just say whatever, and then ident_type. They need to match. The identifier expected something, but got something else. So what we have to do is var type this symbol expected this, but got ident_type. And that should be it, maybe. It is working. It is working. Okay. And if we go back, it is compiling. If we say it's in fact a boolean and we are assigning something different, expected a boolean but got signed 64. Okay. If I say something like this, it should just work in theory. Yes. Okay, nice. So I can just say assign 64 and it works. Nice. That's a little bit convoluted, but again, later this will be updated, will be changed, will be improved, but for now that's working just fine. Nice. Which means that I can just go back to whatever I had before and it should just work. Yes. Okay. Drinking some tea. Now, the other thing is function calls, I guess. That would be my next guess. Is a good thing for us to do. Proc definition for now, I don't want to handle it. That's a whole other stream, I guess. But let's go into function calls. And they are more or less similar, but at the same time not really. They have the same feel for identifiers, but they have some caveats, I guess. So here I don't even have type checking for function calls, I guess. Let's see. Yeah, I don't really have anything for that. So let me just delete this because we don't even use it anymore. Type infer will be using it, but let's just wait. So type inference, we need to check for function calls, which is this. Let's go back here. So if we find a function call, so we have a function here and we are calling this function, and this function is basically empty and returns an empty string. The first thing that we need to do is infer whatever we have based on the output of that function. So we need to do it like this. This is basically the first thing. We need to infer it. We know it is token infer, we need to check if it is in fact in scope. If it is, then we do something and then we break because we already found it. That's fine. Now let me go back all the way up because there's a lot of things in here that I need to do actually, and I will just copy and paste it because they are almost the same but not really. So here and we just need to comment it out. So I don't care about this, I don't care about this. Also very important, what is this? We can just return later. No, what? So we know it is identifier, so we don't need this. But instead of name, I mean instead of variable declaration, no, this is fine. Instead of assignment, we need to check, no, sorry, not assignment, but variable declaration. It's a call name symbol. We need to check for that. The other thing, and it's very important for now, and I will just copy and paste because I remember this, we need to have it like this. And this is basically checking for the return length. If it is greater than 1, we don't support it for now. If we don't have any return types, we are basically setting this to void. If it is equal to 1, we are basically getting the only one that is available. And that's it. Kind of. We can just delete this. Is this approach valid? It is because we are inside of the scopes. Yeah, sure, that is fine. Then later we need to, it is in fact identifier. We kind of know that already, I guess. Yeah, so this part right here, I don't remember why I need to have this specific thing, but I remember there was a reason, but I don't know what is the reason. I don't remember the reason for that. I know there's a reason, but I don't know why. But there was a reason. So anyway, if we don't infer anything, it means that we need to type check. Sure. Oh yeah, so yeah, sorry, this needs to be inside of here because this is the next step. We need to update the scope with everything that we found. The same behavior. We updated the node, but we need to update this value in the scopes so that later if we ever use this, it is correct. So we get, yes, I remember now why it needs to be a node. Right? It needs to be node identifier, and then not only that, we need to find the symbol that matches whatever we have right now. And if we do, it means that we found it, and then we can just break it. And that's it. And that's fine. So this should be working already. Did I forget to return? So it worked. Is it even reaching? Sorry. It isn't, so I did something wrong. What we have in here? Variable node call. Why though? Function exists. In fact, it does. This is a function call. So why it skipped? Don't know. What we have in here? So function variable declaration assignment, it's a proc. What? Why it's not a function called oh no, sorry, I see the problem. This is the problem. Yeah. So let's do this. Yeah, so this is something that I know. Yep. Let's go it in here, and we can just like, yeah, we don't know what we are doing here right now. Yep. Okay, that's the problem. Okay, so it is working already, and we can even double check it. So if we look into the actual node, we should be seeing the correct thing. It is a function call, it is a string, yeah, and you can confirm it in here. It is inferring that it is a string based on this. Nice. And also let's look into the scope, and let's do this. Actually, let's have it like a is equal to 0, and then let's say that a is equal to index, and then we can just look at this scope in here, and that should be, sorry, $279. It is the same thing. Okay, so it is in fact working as expected, so we don't need to worry about it. It is inferring the callback, the function call. Now we need to type check when we are calling the function. So with a specific type, because for some many reasons actually, we may be calling something, and when we say like this should be a boolean for some reason, and then when we call it, it should see that it's in fact incorrect. Right now it doesn't, because we don't have it implemented. So This is actually very tricky as well because we need to do a bunch of shit. How can we do that? I think we can do something like this as well. So this is not the verb. Yeah, this is the variable type. We got it. Now that's where we need to do different shit. Right? Because we do have the variable, but we need to look for something different. And it's not variable declaration, it's call name symbol. That name should match something in the scope, and if it does, that is fine. We get that type, and it should, yeah, but the way we get the type is different, I guess, because right now we don't have a way to have a signature. We need to do it differently, because if we do something like this, it should fail or not work properly. So we can even check it. So is it reaching? Is not even reaching. What do we have in here? Function call. Do we even have this? No. Why? Because we never said that to fall inferred. Oh, yeah, so that's the problem. It should be later. It's not part of this monstrosity. It is, yeah. Yeah, now it is in fact working, but not really. Yeah, so we do have that as a boolean. So we don't really have that in here as I was doing before, because the variable declaration, we don't have a type for that. So the assignment, we need to get the proc definition, and then we need to get the outputs for that. And then we need to do something similar to what I did in here, which is basically do this. So we need to know the return type. It must be greater than 1. So actually, less than or equal to 1. Sure. And we are always getting the 0th because it is always something in here, and this is the identity, and then we get the, where is the thing, I don't remember, variable declaration type. Yes, that should be it. Yes. So as you can see, we are saying, okay, I need a boolean, but this function returns a string, so it doesn't work. Now, if I change this to Boolean, even though it's not even remotely correct, right now it should work. It in fact works. But if we change it back, it fails, as expected. Okay, that is cool. That is very cool, actually. Which means that we no longer need this old code that I was using for inferring types, because everything has been ported to this new function here that does both of them at the same time, which means we can just remove this and it should be just working. Yes. And then we can just infer things as we see fit, and it should be just working. Yes, it is. Cool. That is actually super cool. Okay, let's see something. Oh yeah, there's no diff because yeah, that's understandable. I renamed things. Okay, so if we do it like I don't even know if this is going to work. Actually, let me see. Yeah, it doesn't, because it's a different behavior, I guess, that I don't want to handle right now. Just for you to know, basically this we are stating a variable but not initializing it, and then we are initializing it, and we are not covering that specific interaction, which is it is a identifier, but in addition to that it already exists, and we are assigning a new value, and that value must match whatever we had previously as a type, and we don't have that already. We don't have that implemented, sorry. We just have for definitions and initialization, so it should work. Yeah, so this is just an edge case that I need to implement later, but I don't feel like doing it right now. Yeah, later I can do that. So let's push this to the repo, git status, what we have. So git add, let's do chaos type checking, chaos type inferencing, and then chaos inference type. Yeah. How can I, let's say, unifying, is that a word? Unifying. Yes, it is. Unifying type checker and type inference. Good. Looking good. So it is in fact working. Now, the thing that I want to probably do, just because I think it would be fun, is type checking a few different keywords. So if you take a look at the main two, we do have, for instance, exit. So I want to type check exit. I think this would be fun. Also, maybe we can type check binary operations as well. And I think offline I will just implement this type checker for functions, because for functions there's a lot of things that we need to do, right? We need to first know the signature, which is whatever comes in here. So whatever is in here is the signature of the function, and it is considered a type. But not only that, we need to type check here whatever we have in here, and then whatever we have in scope, and then if we have something like this, it should type check as well. So there's a bunch of things that we need to type check. So something like this needs to be type checked. So yeah. And also things like this should work. This is a default value, and this would be Boolean, and it should be inferred as such. But it's something for later, I guess. And also returns. So there's a whole bunch of things that we will have to do to make sure that when we have return, it must match this. And it's not even considering errors, and errors, it's a whole thing, but you know, it's not for now. Yeah, but I think I'll do a small break because I've been streaming for like almost 2 hours, and I want to use the bathroom, and I also want to take something to drink as well. So I think like 15 minutes break should be okay. Small break. Be right back. 15 minutes. And then let's say that it started like 1 p.m. for me, 1 a.m. for me. So be right back. Hey, hey. Well, I have some coffee in here and some Coke Zero, I guess. And I know it's 1 a.m. for me, but I do want some coffee. Am I going to sleep? Oh, yes. Very, very deeply. So let's go back in here. And the next thing that I really want to do is this. Type check this. And it should be simple, pretty simple, in my opinion. So let's go. So now we need to do something a little bit different. We need to check for node exit, I guess. If CS match, we pass the program, we pass this filter that we need to do, and then node exit. If we have it, we are basically doing the same thing, but instead of identifier, it is exit, and we need to pass the exact same thing. What is this? Then we need to consume and continue. Now it doesn't really exist, so we need to create this. So this is the function. We are expecting a program that is a pointer to the slice of nodes. And then the scope, which is the global scope. And probably later we need to pass a list of scopes instead of a single scope, but that's for later. So here we don't really need to infer anything, I think. Do we? I don't think so. We just need to type check, because exit is just we have a few different options. We can either have exit as a number in here, we can have identifier in a string, we can have number identifier, and we can have identifier and identifier, and also we can have like this and like this. These are the 6 different options that are available for us. And for now I don't have negative numbers because they are kind of annoying to implement, and I don't want to do that right now. So we are stuck with this. It's either number in string and then number, or identifier, or number and string, or identifier and string, or number and identifier, identifier. So let's take a look at how I am doing this in the AST, because I don't really remember. So we have open bracket, this is the scope, this is the identifier, this is the exit. So not this, but actually this. So we get it, we check if it exists, and that's it. Okay, so let's go back to here. we need to get the node first thing, cs get, and we can get that by value because we don't really change anything. We will not change anything. Then no.exit, because we know it is in fact exit dot message. So first thing that we need to do, does message exist? Can we, if we go back to here, then here, what huh? What is this? Where am I? Sure, okay. So whatever, let's go back in here, and then go back into here, and then in here. So the status, it's in fact a node. And what I am setting as the, okay, let's go back. So this is basically a variable declaration, node type. We need to do a few things in here basically, because node type can be null. So if this is null, node null, why are you like this? Stop. If it is null, we are just, if it is not null actually, or let's start simple. Let's go first with the message, because the message we kind of know, not the message, the status, node type. If it is node integer literal, if it is, so we can do even simpler. If it is not like this, or why, what the fuck? So it needs to be integer, or it needs to be a identifier, and not only that, but also the variable declaration type dot symbol yeah, let's do the following because it's a big expression and I don't want it like this. So status condition 1 it is node identifier, and not only that, we also stats conditions. So this is the first condition. The second one is that this and then we need to go back in here and we need to get this, and for now it's only unsigned values. Maybe we can have both, I don't mind. Yeah, so let's do it like this. So these are the allowed types. And I am allowing everything, but I probably can do a to-do in here. Later we should not allow all the types in here. Probably just you wait and sign date. And because why am I doing something like this? Because when we are doing a syscall, the exit so the exit is limited, the number that it is allowed in the syscall. We can even probably take, let me do the following. So let's go syscall Linux table. Let me see. Exit. So if I'm not mistaken, so the syscall number 60, it has a size of 8 bits, if I'm not mistaken, which is 256. We can even try something. So if we so if we go into here, and then we can say something like user being env, and then we say bash, and then we have like exit with 1000. I don't think it is going to work. Sorry, I need to actually do this test.sh, and then we can do, and then if we echo this, it should be a different, yes. So basically what it does is it is modding this, and you know, the modular operation by 256 if I'm not mistaken. So we can maybe take a look at this. So if we do something like 1000 mod 256, yes, that is exactly what it is doing. So again, we can test it just to make sure. Yeah, so we are and we can even try to do something like minus. I don't know what will happen, but we can look. Is 24, which again, if we do what I was doing, so instead of this, we're doing this, it mods things. So later we can update this, and I mean, do we something, I am not sure about this, since we can just mod by 256. I should think about, because I'm not sure what is the best approach in here. Probably we can just mod it and that's fine, but you know, kind of annoying. but if you're programming in this language, you probably should know this because it's not supposed to be safe or anything. So yeah, let's see how it goes. And then we can type check literals. I think that's it. And then it's the variable, which would be status variable declaration type, and then the allow types. So if we don't have any of them, we should just assert false and just give an error message saying that someone fucked up. So fmts printf. So what should we say? Exit expected expects signed or unsigned integer as status code, but got something else. And then we can just have the node to string, and then we get the node type. We can even do something a bit different as well. Because in here the status doesn't match. So what is the cause of it? Status condition 1, condition 2. And then we can say something like, okay, if not either of those, which we can even simplify with something like this, I guess. And then we can just say like this. If they fail one or the other, we can have different error messages. So the first one is this true? Is this false? If so, actually, so we have a bunch of conditions for this to work actually. So we need to have a third condition, which is so this should be condition number 2, this should be condition number 1, and instead of the status, instead of let me do something different. I don't know what we got in here, so I hate this to do. I hate having this fucking language as a anyway. So what we have in here as a node dot exit dot, no, that's fine. So I want this first one, and I can probably just comment everything out. So if it is in fact an exit with an integer literal, we have the node type of that as So the first condition is basically node dot is exit dot status dot node type is equal to node int literal not identifier int literal, and this is condition 1. Right? Yeah. Condition number 2 so let's start simple then. If not condition 1, we have an error. So we assert false. fm test printf, and then we can basically say that exit expected int expects int literal but got whatever, and then we can just say that this is what we have in here. So this is the first one. No to what the fuck? What? No to string. So this should work if it is in fact working. Now if I change it to something like this, it is going to fail. And the important thing here is that probably later I need to create a function that gets the type based on the node, but whatever, that should be working for now. So this is the first thing. Let's go back to integer. This is the first condition. The other condition is, okay, we have a is equal to 1, we allow a. This should fail. In fact, it does. So the next condition is condition number 2. If it is an identifier, it is okay. And not only that, we have the condition number 3, which is this right here must match the allowed types. And technically they should be executed simultaneously, I guess. So we can say something like, and condition 2, and also we need to have, because it is going to short circuit, so that's fine. So what do we need in here? We need let me go back. we need node exit status variable declaration type, I guess, and that needs to match the allowed types. So if I go back in here and I get this, does that work? I don't know actually. So let's do it like this, and then we have condition 2, and then we have condition 3. And it's not actually. Something is not working. So what is this? So I want to do the following. I want to print this. Then I want to print this. It doesn't really matter. And then I want to print condition 3. Which is, sure, let's just get this. And let me just remove this to do because it's a very annoying. False, true, false. So why the third one didn't work? What do we have as the third condition in here? So let me check the actual, not this, but the fucking theme. What is here? Fucking Go language. I hate it. So it's an empty. Why is it empty? Because I need to check the scope, probably, because in here we only have the type. So yeah, let's do the following. If we have the whatever and then the node, and then we are looping through the scope, we are looking for dot name dot symbol. We need to find it. Is equal to node dot variable declaration dot name dot symbol. And then let's see if it is in fact, if we ever reached. No, what? We have reached twice, which, okay. we can then break, that's fine. We only care about it once. And not only that, I want you to see the node. And we got A is assigned 64 and the value is in fact 1. Yes, so yeah, we need to check in here, and then if we find it, that's a valid thing, which means that we need to use this instead of whatever regarding the actual identifier, because this is the relevant thing. So if we do var declaration type, we should be able to see sign 64. And then if we basically do this, but instead we use this right here, it should be true or something. Yes. So if we just do what the fuck here, and then let's just remove this, we should be able to see just one true, which is fine. So we need to check the scope. Can I even do something like this? No, annoying. Okay. Then so we have that already. Let's go to what I was thinking. If we have something like this, no, sorry, what so this is condition number 1. Then we have condition number 2. Condition number 2 is it is in fact identifier. Condition number 3 is this. So if condition number 2, we need to find condition number 3. And then we can just say condition number 3 is equal to this. And then we break. And that is fine. Now we can go over the different errors. So if we have this, if we don't have this, or the other one, so it's this, not this, or we don't have these two, this, if we don't have this, basically we have an error, so we can even double check. So if we reach, we did reach it, which is not correct, I guess, because it should be fine. Let me then why are we breaching if we shouldn't? Shouldn't it just work? So is it equal to node identifier? Int literal? It is. So if not, that is false. So let's then that is kind of annoying. So if I do it like this and not this, Now if I do a little bit different and I say this is in fact a string, it should fuck. So what is this then? It is false. It is false. And this is true. Why is it true? Yeah, I mean, sure, it is okay. And then condition number 3, it should be false. Or am I doing something wrong? So it should be like this. And then we reached, okay. So it's either or no. So it's false, true, and true. So I think that is fine now. Because we did reach and we were not expecting it. Now if I change this to 1, that should be why? It is true, but it should be fucking annoying. Because we have different conditions and I want to use different errors for them. This is kind of annoying. And I'm too tired to think. Let me drink some coffee. I basically need to think about a truth table that works for this specific situation. So we have a field A. This field A can be integer, it can be identifier, and that's it. But not only its identifier, but also a specific type. So if we have 3 inputs, 1, 2, and 3, and I want basically different outcomes. So out1, out2, out3. So the first one do we need 3? No. So let's do this, just this one. Input 1, input 2, input 3. So if we have input 1 as true, it means that it is in fact correct, and these are false and this is false. The other one is this is false, this is true, and this is true. Which means for me to get this, I need to basically invert the input 1, right? So we would be not in 1, and in 2, and in 3, right? And for this, if we had false, it would have to be the other way around, basically. So in 1 and not in 2 and not in 3. That would mean that this is false, and therefore we can move on because we are in fact correct. So in the end, we would have something like this, right? This is the first situation, not 1 and then this other true. No, it is in fact Golang actually, but I am building my own language, so I can show you. So if we go here, I am building my own programming language. As you can see, there's a few examples in here, but I can show a better one. So just like any other language, we can have functions, we can have definitions of variables, we can have conditions, we can have exit if we want to, we have returns, we have binary operations, we have a bunch of things for now. We have scopes also. I've included scopes in the programming language as well, but it's pretty basic right now. There's a bunch of other things that I plan on doing later. I can show you some of the things that I have. So for instance, if we take a look at hash tables, I do have plans for maybe having methods that can be overloaded. I also want to have compile time logic that you can basically check for types, check for sizes, run compile time operations before runtime. I do want to introduce structs as well. I don't know what I want to do about generics right now. Basically, I want to do a little bit of a different approach to generics. So instead of having like something like key, should be I don't know, iterable or something, and then we have value that should be string or something else. You know, I want to take a different approach, but I'm not really sure. What I was thinking is basically having like, okay, this is a struct, it accepts a key and then a value. And then if you want to, one of the things that you can do is say that this is a maybe a literal or something, which is a compile time thing that you can do. So for instance, if you want to have a, in this case it's a hash table, right? We could have like a hash table that is like a entry, and we basically say that it's a dynamic thing, and then we have something like int or sign64, and we can initialize it or something, and by default it will be dynamic because we have that defined. But I'm not really sure about it yet, but there's a bunch of things that I want to plan later when I have something actually properly compiling and working. Also error handling, there's a bunch of different things. But yeah, this is my language. I'm creating it just for fun. Hopefully that explains what I'm doing. And what we can probably do is something like this as well, and that should probably work. And it didn't reach, sure. Now if I change this to string, it reached. And if I say this is 1, yeah, so that is messed up. So let's get this and this, and I basically need to do this and this. Let me think about it. So the first one is okay, and this is not this and not this. How can I so the first thing is basically I need this condition or I need the other one. Because it's either this or this. So if the first one doesn't go, because I think it's short circuits, so we basically need to we say if not this, we have an error. Then if this and this are correct, which should be like this, it did reach, which is not correct. Is that it? I think it is. I'm tired. I'm trying. I'm brute forcing it, and I'm not being really successful. It shouldn't. Okay. Now if I do it like this, it is in fact reaching, and if I do it like this, it shouldn't. Okay, finally. Jesus, I am just tired. Just for the sake of testing, once again, If I do it like this, it should be reached, yes. If I move it to 1, no. And then here, if I do it like this, no. Okay. Fuck, finally. I'm just tired, I need to rest. So if we have it like this, the first thing that we need to do is this the condition that failed? If it is, we can say false. We can assert false. And we can say expected integer but got something really weird. And we can probably just get the type from this, and that should be fine because it's a literal, maybe. Let's see. Dot type dot symbol. So let's see. It is working. Now if I say this is a string, it should fail. Did I? Yeah, so. Huh? Oh, right. I need to check the scope. Which is different. It's a different thing, so let me do it like this. Yeah, later I need to change it. Let's keep it for now like this because I need to have a function that returns the type based on the node type, and I don't really have it because, you know, I never implemented it. So yeah, whatever. And then we need to have it like this. What the fuck is that noise? The street? Hopefully you guys cannot hear this, but it was very loud. I can even do it like else if. We are also asserting it false. We expect exit expected identifier should be integer, but we got something completely different, and we can probably save this. The identifier, we can just say it's a node, and then we can do it like identifier is equal to n, and then we can just say like we got something that we were not expecting, which is n dot variable, not this, it's identifier dot type dot symbol. Yeah, sure. And now we do a expects integer but got no identifier. Why is it going here? Am I crazy? Yeah, it is working. It is working. Expects, okay. If we have it like this, what, just fail and that's it. Later I can just think about a better approach to this. I can even just yeah, I don't really want to think about it right now, and if it is working, it's fine. And then if I do it like this, it is in fact working. If I say this is a U128, it should still work as well. It is. And then if I say like this, it should fail. Yes. Yes. Yeah. Okay. The first part is okay, and it is in fact working, and I don't want to think about it longer than that. Now the second part, which is a string, which is optional, by the way. We can check if we have the node exit message and if I'm not mistaken, yes, and the node type is not equal to node no, then we have reach. And right now it should fail. I mean, not fail, it should work because there's nothing there. Now if I do it like this, it should, yeah. So if we did reach, we need to basically do the same thing we did in here, but instead of int literal, we need to have identifier. I mean, sorry, instead of int literal, we need a string, and instead of having this allow types, we basically have a string. So I can just copy and paste this, and then later I can just refactor it. So allow types is just string. Instead of int literal is just string literal. And everything else should be just fine, just like this. Expected string. What? Exit, yeah, so that's not a start yet. So this is message. Let me do the following. I will do this and then do this, yes. So copy. So let's do it like this and then paste it and then stop. And like this and then like this. And that should be not it because I need to move it in here. That's it. And it is in fact working. So if I come here and I say this, it should fail. Yes. And if I have like B, and B is just another, it is working. Great. Now should do improve this fucking shit because the error message sucks and it doesn't tell anything to the user when there is an actual error. The same goes in here. That's okay. Now, I think that's it. I think that's everything for exit. I thought it would be a lot easier, but it's not really that easy to do the type check for this. We can try something like true. Yeah. And if I do it like in here, it should also fail. Yes. Great. And if I have just exit A, it should also work. It is working. It is working. Nice. Very, very nice. Oh, yeah. We can even just uncomment everything, I guess. And then we can just say like, okay, we are exiting with value 1 and then value 2, and that should be working fine, as it is. Great. What do we have in here? And also let me remove this. So git restore the src chaos utils, git status, git gif source inference. We basically included a new function in here, infer and type check. Yeah, let me change the name because we are not inferring anything anymore, or ever actually. We are just type checking to see if it actually matches what we are expecting. And then in here we need to change in here, and it's fine. Yeah. What else? We have these conditions, that's fine. We include, yeah, okay, git status, and then just let's add this character, yeah, git commit including type checking for exit keyword. What did I change in main? Sorry. Oh, it's just, okay, sorry. That is fine. It doesn't really matter. What should I do now? And I think that I will not be streaming a lot of type checking anymore because it's kind of boring. Or, I mean, it's not exclusively type checking kind of thing, because it's kind of a lot of repetition. Basically, it's just doing everything that I just did, but instead of doing the node exit, I would probably do 2 if statements and then binary operations. So if we take a look at the main 2, the next logical step would be if conditions, or I mean not even if conditions, but the next logical step would be binary operations, type check them, which is by itself kind of annoying, right? Because what I have in mind is the following. if we have something like val1, and this val1 is assigned 64 and it's equal to 10, and then I have val2 and this is assigned 32, what, 32 and it's equal to 10, and if I do something like assert val1 is equal to val2 or something, this should be a compile time error because they have different types and there will be no implicit conversion. If you want to have a comparison between them, you'll be able to do that using something like this. That will actually work, but if you don't have it, it should just fail. Now, if we have something like this as 64, and then we have true or something, then first we need to check, is this sign 64 equal to this value in here? First of all, the comparison, they need to match the type, and this basically will return a boolean, and booleans can be used with the AND operator to continue the evaluation. We can't do something like AND 10, for instance. That is a compile time error. So we need to have this different approach to compare things and use the AND operator and OR operator, and they are kind of overloaded. Not this, but this is overloaded in a sense, or I mean, it's not even overloaded, I mean, kind of is, because we can either do it like this, or maybe like sign 32, then we are basically casting this into a lower number of bits. So, and I mean, it's not even that it is overloaded, it is technically not. It is just comparing not only the value, so it is not comparing values at the type checker, it is comparing types, and we need a whole thing just for that, which is kind of annoying, because at the type checking we don't care about values, we will kind of care about them if you are casting this value, but not at the type checker. The type checker, we just cast it and that's it. If they match, just move on, and that's okay. And the same goes to any other operation, like this, or this, or this. Like, you know, the operator itself is not overloaded, but it needs to match the types. So it's kind of annoying, I don't know. I haven't thought about it, how to implement this, but I don't think I want to do it today because it will take a while. I need to think about it. There's a lot of back and forth, and I need to do some testing, which I don't feel like doing. So yeah. And after that, it's easy to just type check if conditions, because we always have the if and then a bunch of conditions in here that is true or false, and it's easy to check what is the type of operation that is happening and if it is returning a boolean at the end of the day or not. Because yeah, we'll always be returning some sort of boolean after this, after what I was showing. So this is a boolean operation at the end of the day. This technically is comparing two values, but they, yeah, you guys get it. I don't need to explain this. It's not like you are watching this and you don't know what is a fucking programming language. But yeah, I think we had pretty good progress, and I think I will stop it and I will think about how to do these binary operations later. How I would type check them actually, and then let's see how it goes. But yeah, for now I think I'm done for the day. It's almost 3 a.m. for me, and I need to wake up tomorrow to work, so I'm a little bit tired. So yeah, thank you very much, guys, and I see you on the next stream. See ya.